So this is example 3 for the 2.2 day 1 notes. So this is where we are evaluating our polynomial function. Now last time, right here, we used direct substitution. That meant you took your 3 or whatever your x value and you plugged it right into each of the places you see for x. And when we did that, we evaluated it and we got 23. Now we're going to use the same function, same polynomial function with the same x value and see if we get the same answer with what we call with synthetic substitution. Now we're actually going to use synthetic again, but we're going to use it with division, and it actually helps us to divide polynomials. But let's go ahead, let's use synthetic substitution. So the first thing is we're going to take our x equals 3, and I'm just going to write it right here. With this 3, I'm going to create just a little box around it, okay? Now, what I need to do next is write each of the coefficients of our polynomial, okay? So our first term, the coefficient is 2, so I write it 2. Now remember, we're going in descending order, so we go next to our x cubed, and the coefficient for that term is to the negative 5. Now if you notice, we have x cubed and we have x. We're missing actually a term here. So in between here, we would actually have x squared. But because we don't have it, right, we have a 0x squared. So whenever you're using synthetic substitution, you have to account for all of your exponents, even if there's not one there. If there's not one there, then you replace it with a 0. So the first coefficient was 2 from our first term. Negative 5 came from our second term. Our third term, which is the x squared, that's going to be actually 0. So we have to write a 0 in there. Now our next one is, we go right from our x squared to our x. And that coefficient is going to be negative 4. And then our last term is our constant, which is 8. Now go ahead and leave some room here and just draw a line. The next thing we're going to do is we're going to take our 2 and we're going to just bring it down below the line. So that's going to be a 2. Now what you want to do is every single time you have a number below this line, you want to multiply it by 3. So we take 3, we multiply it by 2, and in the next empty spot we have above the line, we put that number, which we should get 6. So we did 3 times 2, that gave us 6, and we place it into our next empty spot, so right here. Now in this case, we're always going to add our numbers. So we're going to do negative 5 plus 6 to get our next number, which should be just 1. So we should get 1 here. Now once again, we multiply our 3 by this number of 1, and we get 3 again. So we place it in the next empty spot, which is right here. Okay. So once again, we add our numbers. I'm going to erase this so you guys don't get too confused. There we go. So we add our numbers. So we do 0 plus 3. And at the end, we should get 3 as well. So we get 3 down here. There we go. So now we do the exact same thing again. We take our 3 and we multiply by 3 here. So we should get 9, and we place it right here. So now once again, we add our numbers. So we do negative 4 plus 9. That should give us 5. And then we do 3 times our 5, and we should get 15. And then once again, we add our numbers. So we do 8 plus 15. That should give us 23. Now, the last number you get, this is actually going to be your final answer. So here, if we plugged in, right, our x equals 3 into our function, we should get 23 as our final answer. So to write this out, we have f of 3 equals 23. And here's our solution. There you go. So whatever you get at the very end after you've added the last two numbers, that will always be your final answer when you use synthetic substitution. Now, the homework for this, it will be on Google Classroom, so make sure you get that, okay? And it's just working on evaluating polynomials and stating if a function is a polynomial, okay? So make sure if you need to use the book, you can if you need to. And really the pages are, it's going to be 99, and it's going to be 4 through 20 even, and then you're going to also have 54. And remember, this is due tomorrow, so if you have questions, make sure you email me.